All right, so we are going to have a pre-calculus problem of the day today from systems of equations and using matrices to solve these. So you likely have seen in Algebra 1, Algebra 2, um, solving a system of equations, usually just two. Maybe you've done three equations and three variables. And likely until pre-calculus, you may not have seen matrices too much anyway. So we're going to use matrices to solve these. Now, a matrix is it's an array of numbers, and for our purposes here, the array is the coefficients of our three equations. So we're gonna write this here, and then we'll solve it on another page. Um, so we're just gonna take these coefficients. Don't need the variables. We know that, and if you like, you can put a dotted line there. We probably won't do that the whole time. But a lot of times that's just kind of signify over here we have the answer, or here's kind of the equal. Over here we have the answer. Over here we have the variables. So we're just writing the coefficients. One thing you want to make sure you do um, is keep the variables in order, which most of the time they're not going to mix up the variables. But if it ever was that way, like you had negative y plus 4x here, you would need to switch those back. So this column here is your x column. This column here is your y column. And this column here is your z column. And then this column here is we just call the solution. Not the solution to the system, of course, but uh, the other side of the equal. And so when you're doing these, it's very important to be, I guess we should say you should be confident in the process that we're going to do, because it is very easy to make mistakes as you go. And any little arithmetic mistake causes the whole thing to be wrong. Especially if you make a mistake early, then they're all going to be wrong. All your in this case, we have a solution with three numbers. We're going to have an ordered triple. So if you make any mistake anywhere, at least one of them is going to be wrong. At least either the X or the Y or the Z is going to be wrong. The earlier you do it, the more likely all three of them will be wrong. So I always use a calculator for these, even if you're just doing something as simple as 1 plus negative 1 or 1 minus 1. Um, just more for the habit. I don't do mental arithmetic on these, just again because um, any little mistake and you got to start over once you realize you got the wrong answer. So we'll go to another slide and work through this. Okay, so here we have our coefficient matrix. Again, we're solving a system of equations, and so we have our x column, we have our y column, and we have our z column. And so, like I just said, it's important to make sure that you're confident of the process, so that if you get to the end and you made a mistake, you know that it's going to be from the arithmetic and not from not knowing what you're doing. So the process, and there are two different ways you could do this. Um, One is called Gaussian elimination, and that's the one we're going to do here. So Gaussian elimination is where we're going to get anything under the main diagonal to be zero. So we have our main diagonal here. We want to manipulate these in a way so that we get zeros in those three spots. And anything on the main diagonal or above it, we don't really care what it is. And then once we do that, we can get back substitution. We can use back substitution to find the answer. So this is going to be three steps to get the elimination to where we want it. Now, to get these two to be zero, we need to use the first row. So using the first row and using the second row, how can we get that to be a zero? So it's really just a matter of picking whatever is convenient. And so, and the way I write these, I'll write the coefficient and then the row as just a number, and then the row I'll circle. So we could do 2 times row 1 minus row 2. So we're going to keep the first row the same. We're not going to change that one at all. And so now, and like I said, use your calculator, even if you can do all this math in your head, but trust me, use your calculator or else you will make a mistake somewhere. So what we're going to do, 2 times row 1 minus row 2. So we have 2 times 2 minus 4, and that gives us a 0. That is what we want. Now, the rest of the row, we're just going to kind of let it play out, however it ends up. Next, we have 2 times negative 3 minus negative 1. That gives us a negative 5. Then we have 2 times 5 minus a negative 2. That gives us a 12. And then we have 2 times 14 minus a negative 17, and that gives us 45. Now, don't worry about, you may get big numbers. Don't worry about that. So, I mean, like I said, you want to get a 0 here, as long as you're doing your math right, whatever this is, just let it play out. Now, you can just copy row 3 if you want, and then take care of row 3 in the next step. We're gonna do take care of both these at the same time. Now, you can't really take care of, say, the X column here and the Y column here in the same step, but you can work with multiple rows together. You cannot work with multiple columns together, but you could do multiple rows together if you like, if you're comfortable with it. All right, so now we need to get a 0 here where this negative 1 is. So let's do 2, or row 1, I should say, plus 2 times row 2. Okay, now let's stop here. Now, how do I know? So this one we did a minus, this one we did a plus. How do I know that? Well, if these two are the same sign, we're gonna have to subtract. And then these two are opposite signs, so we can add in order to get to 0. Obviously, adding any two positive numbers is going to give you more than 0. Or if you take a positive number and subtract a negative number, that's the same as adding two positive numbers. So whatever, if you have the same sign, you're going to be subtracting. If you have different signs, like between row 1 and row 3, you're going to be adding. Okay, so we need row 1 plus 2 times row 2. So 2 plus 2 times negative 1, that gives us a 0. Negative 3 plus 2 times negative 1 will give us a negative 5. 5 plus 2 times 1, that gives us a 7. And then 14 plus 2 times 3, that gives us 20. Okay, so now we took care of these two in that first step. So we got those taken care of here. Now the next thing we need is 0 where this one is, where the negative 1 is. So again, we have the main diagonal here, the 2, negative 1, 1, and we need zeros below that. And once we get there, then it's pretty easy to find out what the answer is. So let's do this next step. Now this one, we're going to leave row 1 alone. We're going to leave row 2 alone because we already got that one the way we like it. And then the only thing is now we need to get this negative 5 or negative 1 from the original matrix to be 0. So now we're going to use row 2 and row 3. So essentially wherever the diagonal, wherever you are on the diagonal, so first row, first column, you're going to use row 1 to get zeros here. Once we get to the second row, second column, we're going to use row 2 to get zeros under that. And if we had say 4 variables with 4 matrices or 4 equations, next we'd use row 3 to get a 0 in the fourth row. So row 3, column 3. So now notice negative 5, these are the same. So all we got to do is subtract row 2 minus row 3. So we have 0 minus 0, negative 5 minus negative 5, 0, 12 minus 7, 5, 45 minus 20 is 25. And so now we're ready to get the answer. It's as long as you get well, I won't even say that because you could get fractions. I was going to say as long as you get a nice answer, then you're good. But sometimes these don't work out. to where you get integers. Sometimes you get fractions. So you can't always go with getting a nice, easy answer, but you can't always check your answer on these. So let's rewrite these as so we got this matrix from the coefficients of our system of equations. So let's write these back. And you don't have to do this, but kind of when you're beginning, just to kind of make sure you know what you're doing. It might not be a bad idea to rewrite these as equations. So all we're going to do is put an x in front of this, a y in front of that, a z in front of that. This is just a constant. So then we have negative 5y plus 12. Sorry, that should be a z equals 45. And then we have 5z equals 25. And so hopefully you can see what we need to do here. We're going to start with this equation, solve for z. Find that z, plug it in, solve that for y. So we have y and z, plug the y and the z in here, and then we can solve for x. So 5z equals 25. Obviously, z is going to be 5. Now plug it in. Now we're just going to work up. So negative 5y plus 12z, but z is 5, equals 45. So we have negative 5y plus 60 equals 45. Negative 5y equals negative 15. So we get y equals 3. Now take the z equals 5, take the y equals 3, plug them back into this first equation. So we have 2x minus 3 times 3 plus 5 times 5 equals 14. So we have 2x minus 9 plus 25 equals 14. Negative 9 plus 25 is 16. So 2x plus 16 is 14. Subtract 16. We get 2x equals negative 2. And so x equals negative 1. So now probably you need to write your solution. We'll just say you do. You need to write your solution as an order triple. So instead of an xy ordered pair, we have an xyz, which would be an order triple. So xyz, so we have negative 1, 3, 5. And then that is our final solution. Now, I worked this out beforehand because, again, it's easy to make mistakes. And you can get to the end, your answer, just looking at this, you can't just look at that and say, oh, this works for that equation or the system of equations. So always check these. So all you need to do, go back to the original system here. So 2 times negative 1 minus 3 times 3 plus 5 times 5. Does that equal 14? I believe it does. Get the second equation, 4 times negative 1 minus 1 times 3 minus 2 times 5, and that should equal negative 17. And then negative 1 times negative 1 minus 1 times 3 plus 1 times 5, and that should equal 3, and it does. So always a good idea to check those because, again, you can't really look at it and tell what the answer should be. Or if your answer is wrong, you can get fractions or whatever else. You're not going to get irrational numbers, but you can get any kind of fraction, really. And again, trust the process. If you're confident that you know what you're doing, as far as you want to get a 0 here, a 0 here, and then a 0 here, as long as you're following that order and you know that's what you're supposed to be doing, then if you get the wrong answer, you check the answer that you got. It doesn't work in all the equations. Then you know it's got to be a math, like a arithmetic error somewhere. So the 3 by 3 is a little bit more complex than the 2 by 2 or the 2 variables, 2 equations. So these take a little bit more practice to get used to. But I mean, you can do it. So if you have any questions or comments, any other problems you want me to do, you can leave them, send me an email, however you want to get in touch.